Lesson 14, Hydraulic Systems. In this section, we're going to look at hydraulic systems. These are systems that contain liquids under pressure in greater detail. We're going to start by talking about volumetric flow rate. A very important concept in hydraulic systems is that of the rate of flow of hydraulic fluid. Rate of flow is analogous to the speed in a mechanical system, but it's not the speed at which the hydraulic fluid is moving along a transmission line that is important. Rather, it's the volume of the hydraulic fluid that moves through a particular point per unit time. This is known as volumetric flow rate, and volumetric flow rate is calculated using the following equation. Q is equal to V over delta T, where Q is the volumetric flow rate in meters cubed per second. V is the volume measured in meters cubed. And delta T is the elapsed time measured in seconds. Let's take a look at this example, which asks us to find the volumetric flow rate of a hydraulic fluid in a cylinder. A cylinder has a piston head with a radius of 2.5 centimeters. A force that is applied to the rod which moves a distance of 12 centimeters in 15 seconds. Let's find the volumetric flow rate. So we're pushing fluid through this cylinder over a distance, see if I can animate this for you, of 12 centimeters. And we're going to find the volumetric flow rate. So if we know the radius is 2.5 centimeters and the height of the chamber or cylinder of fluid is 12 centimeters, we can find the volume of liquid or fluid that is being pushed through using the equation pi r squared h, where the radius is 2.5 centimeters. Make sure you square it, times the height, which is 12 centimeters. If we carefully punch this into our calculator, we have 2.5 squared times pi times height of 12 centimeters. We end up with 235 centimeters cubed. So we can find the volumetric flow rate by finding the amount of volume being pushed through in a given amount of time, where the volume is 235 centimeters cubed and the time is 15 seconds. If we punch this in, we get a volumetric flow rate of 15.7 centimeters cubed per second. Excuse me. Now, remember when we talked about the volumetric flow rate, we had the units measured in meters cubed per second. I also want to note that you can also do this in centimeters cubed per second for smaller volumes of liquid, or you can do it in milliliters per second. So this also works. Moving on, we're going to talk about Pascal's principle. If ever you've seen a car hoisted up at an auto body shop or mechanic shop, it's all based on Pascal's principle. Again, it's worth noting that I've put page references here, and you can find these pages correspond to the reference text in the content library. So feel free to access the content library and the reference text there to further your understanding and to get more information on each of these topics that we discuss. So continuing, pressure applied to an enclosed liquid is transmitted equally to every part of the liquid in the walls. And an example of this, an amazing example, is called the hydraulic press. And here's a diagram of a hydraulic press. So inside this hydraulic press, we have a liquid that is sealed, and we have a large piston, whose surface area is large, and we have a small piston whose surface area is small. If you apply a small force here on this small piston, the energy is transmitted in all directions inside this enclosed liquid, and it will be amplified. So a small force on the small piston will cause a large force on the large piston. So you can actually use a small force in this closed system to lift a very, very heavy object. And Pascal was a physicist who summarized these findings in a beautiful equation which basically states that the pressure at the small piston is going to equal the pressure at the large piston. And if you know the equation for pressure, we have the force on the small piston divided by the area of the large piston is equal to the force of the large piston divided by the area of the large piston. And we can use this to find some amazing information. And our first example will show you just that. A hydraulic braking system in your car has a master cylinder with radius of 1.25 centimeters connected to a slave cylinder with a radius of 2.1 centimeters. If a force of 410 newtons is applied to the rod in the master cylinder, what force does a slave cylinder apply to the brake pads? Okay, so we have two radii, rather, the plural of radius. We have the radius of the small cylinder is 1.25 centimeters, and the radius of the large cylinder is 2.1 centimeters. And we're applying a force of 410 newtons to the master cylinder, which is the small one. So the force on the small one is 410 newtons. And we're going to see what force this transfers to our brake pads on the large or the slave cylinder. This is what we need to find. So we have Fs and Fl, but we also need to find the small area and the large area, and we're going to use pi r squared to find both of these. So the small area for the master cylinder is pi times 1.25 centimeters squared, and this one is pi times 2.1 centimeters. Don't forget to square it. So let's find 1.25 squared times pi. We end up with an area of 4.91 centimeters squared. That's the small area. Let's do the same for the large area. 2.1 squared times pi. We end up with 13.85 centimeters squared. So let's set up Pascal's equation, which states that Fs over As equals Fl over Al. And we want to get this guy by itself. So we're going to multiply both sides by Al. If we do, these two cancel out, and we're left with the force on the large cylinder is equal to the area of the large cylinder times the force of the small cylinder divided by the area of the small cylinder. So we can punch this in. That's 13.85 centimeters squared times 410 newtons divided by 4.91 centimeters squared. If we punch this in carefully in our calculator, give you some time to do that, and I'll do it as well. 13.85 times 410 divided by 4.91. We end up with a force of 1,157 newtons. So, applying a small force of 410 newtons on a small piston will amplify the larger piston and output a force of 1,157 newtons. Below we have a diagram of how these brake systems work, and you can see the small piston and the large piston, the slave cylinder and the master cylinder. Here we also have, and this diagram came from our reference textbook, here we have a car hoist, and it's a hydraulic system, a closed system that has liquid inside. And all of the different parts have explanations. And those parts can also be drawn using symbols. And these symbols are well understood by anyone who studied physics, particularly in this area, all over the world. One of the things I want you to do is to use the diagrams above to fill in this table in your notes, in which you give an explanation and match the explanation to the particular points on the diagrams above. You can use the diagrams above, which are directly from your reference textbook, to fill in this table as part of your homework. In addition, I want you to try these homework practice questions. And when you're done, complete the corresponding LMS quiz. So good luck.